Hello dear students, welcome back to the world of current electricity. Now in this module we are going to discuss some multiple choice questions based on the concept of potentiometer that we have studied. Now dear students, in potentiometer we have studied the basic principle as well as three applications, right? The first one was comparison by individual cell method. Similarly, the second one was comparison by combination method, and third one was to find the internal resistance of a cell using the concept of potentiometer. So what I expect you is, before watching this module, please try to revise all the formulas based on potentiometer and its application. So let's start with our first question. The question is depicted as, for a cell of EMF 2 volts, a balance is obtained for 50 centimeter of the potentiometer wire. So when I just connect a driver cell of 2 volts, the balancing length of potentiometer was supposed to be 50 centimeter. Now, if the cell is shunted by a 2 ohm resistance, shunted means, dear students, a 2 ohm resistance is applied parallel to the driver cell. The balance length is obtained across 40 centimeter, implies that the balancing length got reduced. Yes, and I am supposed to find the internal resistance of the cell. Now dear student, the formula is very simple and we have already studied that. By the concept of method to find internal resistance of the cell is given by R, that is your resistance, into L1 minus L2 upon L2. Now that L1 will be the length that was found before the cell was shunted with a 2 ohm resistance, and L2 would be the length that should be obtained after the cell was shunted by a 2 ohm resistance. So what is the value of R given, dear students? Yes, can I say R is 2 ohms? So I'll substitute the value of R. Similarly, dear students, what about L1? Yes, L1 is the length before the cell was shunted with the resistance, so it has to be 50. What about L2, dear students? Yes, you guessed it right. L2 is given as 40 centimeter. Yes, can I say that? Perfect. Now dear students, L2 is given as 40. Again in the denominator I'll take L2 to be 40. So when I substitute and simplify, what I get is 2 into, what is 50 minus 40? 10 upon 40. So the correct answer comes out to be 0.5 ohms. Moving ahead with our next question. The question says, a cell of EMF 1.2 volts is balanced by 150 centimeter of potentiometer wire. Okay, so can I say it is similar to the previous MCQ what we have studied? Yes. When the cell is shunted by a resistance of 4 ohms, similar type of question. Last time it was 2 ohms, this time it is 4 ohms. The balancing length got reduced by 30 centimeter. This is the catch here, dear students. In the last case, we were given the actual length when the cell was shunted, but in this case we were not given the actual length. We have given some relation with the initial length. So if the initial length would have been 150, then the second length was reduced by 30 centimeter, hence it comes out to be 120 centimeter. Yes, this is the catch. And again the question is same, what is the internal resistance of the cell? So again, can I say that by the potentiometer method, to find the internal resistance, R is given as R into L1 minus L2 upon L2. R is given to us, yes, it is given to us 4 ohms this time. So what about L1? Yes, L1 is given to us as 150 centimeter. The only thing of concern here is, what about LU? If you take 30, then your answer will be wrong. The length got reduced. So if the actual length would have been 150 and 30 was reduced, then I can say the length was 120 centimeter. Yes, dear student, so it would have been 120 centimeter. So when you recalculate and apply the mathematics logic, what you'll get the value to be 1 ohm. Yes, that's it. Okay, so moving ahead to the third question. A potentiometer experiment is set up to compare the EMFs E1 and E2. Okay, so that we know that. Of two cells, when the null point is obtained, okay, so that means the condition is nothing but the balance condition. The current drawn is from dash. The options are only the driver cell, only the cell of EMF 1, only the cell of EMF 2, or both the driver cell as well as cells EMF1 and EMF2. Now dear students, if you remember this module when we were discussing, we have studied a very important point that the EMF of battery must be greater than the EMF what is going to be compared, implies E is greater than E1, E2 as well as E1 plus E2. That implies dear students that when the cells are balanced, then the current will be only obtained or it will be only drawn from the driver cell. Perfect. Moving ahead with the last question of this module. In a potentiometer experiment, two cells of EMF E1 and E2 are given provided E1 is greater than E2. Okay. And they are used in series. The balancing length was found to be 58 centimeters. So can I say this is a case of assisting? Yes, assisting of cell. And similarly, when the polarity of E2 was reversed, implies it is a case of opposition. Yes, the balancing length became 29. I am supposed to find the ratio of E1 upon E2. We have already studied this, dear students, that by comparison method, E1 upon E2 is given as L1 plus L2 upon L1 minus L2. So what is L1, dear students? Yes, L1 is given as 58 centimeter. What about L2? Yes, L2 is given as 29 centimeter. So I know the value of L1, I know the value of L2. What I'm supposed to do? In numerator add them and in denominator subtract them. So when you recalculate this equation, dear students, what I'll get is 87 upon 29 and that is nothing but 3:1. So that's it for this module. Stay tuned for the upcoming module. Thank you.